Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to talk about the least common multiple. All right, so before we get going, you know there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision textbook with our little robot friend on the front. Second, you're going to need your math notebook to take those amazing notes. Third, you're going to need a pencil. And fourth, last but not least, you're going to need that positive math attitude. All right, my friends. So if you remember last week, we looked at the greatest common factor, those building blocks for different numbers, correct? And if you remember, it was just part one of a larger lesson, lesson 3-2, which is in your Envision book. The second part of this lesson goes over the least common multiple. So if you'd like to check out the key concepts page for this lesson, it's on page 132. But the first problem that we're going to look at together is on page 134, and it's number 27. All right, my friends, so on page 134, number 27, it's asking us to find the least common multiple between two numbers, 5 and 8. Now, the word multiple, not a new word, you should have heard this before. Does it sound familiar? Does it remind you of anything? So multiple and multiplication, they're like buddies. They're pretty similar. So if you remember last week when we talked about the greatest common factor, we were talking about those building blocks for numbers, right? So if I had a number like 8, what are the different building blocks I can do for 8? Well, I can do 1 times 8. I can do 2 times 4. But multiple is on the different end. I want to know, what can I use 8 as a factor in order to make bigger numbers, right? So first what we're going to do is we're going to list out our 5 multiplication facts. All right, again, all I did so far was just I wrote down the multiples of 5, or I skip counted by 5s, and those numbers that you would count, those are the multiples, right? So I could do 5 times 1, that equals 5. 5 times 2, that equals 10. 5 times 3, that equals 15, and so on. So remember, my friends, in order to get all of these numbers, I multiplied 5 by something else, right? So our multiples of 5, not all of them, just some of them, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So now, my friends, we're going to do the same thing, but multiples of 8. All right, so now down here in red, I have the multiples of 8, or we can think about it as like our 8 multiplication facts, right? Our 8 times tables. So again, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. So remember, my friends, the way I got all these numbers was taking 8 and then multiplying it by different numbers in order to find out the multiples, right? So multiples of 8, some of them, not all of them, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96, and 104. So, my friends, we have now listed all of the multiples of 8 and 5, but we are looking for the least common multiple. So we know that least means tiny. I'm looking for the smallest number. Common means something that they share. And multiple, right? We just wrote those all out. So what we're looking for is the smallest multiple that both 5 and 8 share. So one way I like to do this, my friends, when I'm looking at both of my lists, let's circle any numbers that they have in common. So as I'm looking, I see that there's not a whole lot, because if you remember with your 5 times tables, your last digit is either going to be a 5 or a 0. And if I'm looking at 8, there's not a ton in there. There's 40, right? 40 is a multiple of 8, but 40 is also a multiple of 5. And we know, following that same pattern, that 80 would also be a multiple of 5, correct? We just didn't have it on our list, but it would be a multiple of 5. But am I just looking for any multiples? Of course not. I'm looking for the least common multiple. I'm looking for the smallest multiple that they have in common. And you know, my friends, that that's 40, right? 40 is a multiple of 8. I can do 8 times 5 to get 40. 40 is also a multiple of 5. I can do 5 times 8 to get 40. So for number 27, my friends, when it asks us, hey, what's the least common multiple of 8 and 5? The answer is 40. All right, my friends, so the next problem that we're going to look at together is on page 135, and it's number 35. All right, just full disclaimer before we look at this problem. This is one of those problems that gets super wordy, sounds super duper complicated, but the math itself isn't that difficult. So what we're gonna do is let's look at it first with no numbers. All right, so we got people waiting in line, and I don't know, this show that they're trying to get into is amazing. There's tons of people in line. All right, we got this big old line, and there's some lucky people that are standing in line. So for a certain group of people, they're gonna get a free ticket. Pretty cool, right? Another group of people, they're gonna get a $40 gift card. That's also pretty cool. But there's this third group of people that are the super duper lucky ones. They not only get a free ticket, my friend, they also get the gift card, okay? And the question is asking us, well, who's gonna be that first lucky person to get both of those sweet prizes, right? Now, let's start filling in a little bit more information. All right, my friends, so here's a little more information. So instead of it just being some people in line who get a free ticket, I know that it's every fifth person in line that's going to get a free ticket. And instead of just some random people are getting this $40 gift card, I now know that it's every sixth person in line that will be getting this gift card. So here's also another tip, my friends. If you're having a hard time picturing this situation, let's draw a picture. All right, so welcome back to another fabulous edition of Mrs. Schlecht's Artistry, right? Most fabulous math teacher / artist in the world. Totally joking, right? Yeah. So I'm just using lines as my people in line, right? So each of these lines represents one of our friends who's chilling out in line, right? And now I'm going to start just kind of sketching out some information on here to make sure that we understand what's going on in this whole entire story, right? So every fifth person gets a free ticket. So I'm going to go through here and I'm going to take red and I'm going to circle every fifth person that's in line, right? And that represents that free ticket. All right, my friends. So what I did is I took my red marker and I circled every fifth person in line, and that's representing the people who are going to get that free ticket, right? So this is a lucky friend who gets a free ticket. This is a lucky friend who gets a free ticket, free ticket, free ticket, free ticket, free ticket. But that's not the only super cool prize that they're giving away. They're also giving away that $40 gift card. But who are they giving that away to? Oh, that's right, every sixth person in line. So now I'm going to take my green marker and I'm going to circle every sixth person in line. And again, that's going to represent all those super duper lucky people who get a gift card. All right, my friends, apologies again. This is kind of light. You might not be able to see it. But red was our every fifth person who got that free ticket. Green was every sixth person who got that gift card. And you can tell I have red, green, red, green, red, green, red, green. But this question is not asking us, well, who are all the lucky people who get a free ticket? It's asking us, who are the super, super duper lucky people? More specifically, who is that first lucky person who gets not only the gift card, but also that free ticket as well. And if we're looking towards the end of Mrs. Schlecht's drawing, you might not be able to see it super well, but this last person in line happens to have both a red and a green circle, which means that this person was going to be the first person that got both of those prizes. Now, if you're not really a picture person, what we're actually trying to look for, my friends, is that least common multiple. So let's try to use numbers now. And what we're going to look for is the multiples of 5 and the multiples of 6. So first, again, those multiples of 5, my friends, those are our 5 times tables facts, right? We're skip counting by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. All right, now let's look at the multiples of 6. All right, and so now here are the multiples of 6. Again, just like with 5, these are not all of the multiples of 6. This is just a small sample, right? But multiples of 6, we have 6, 12, 18, 24, 30, 36, 42, 48, and so on. So now what we're looking for, my friends, is what's the smallest multiple or the least common multiple that both 5 and 6 have in common. All right, so what I did was I looked at all of my multiples of 5, all of my multiples of 6, and then any number that they had in common, I circled in blue. One thing I do want to point out, my friends, is that I did circle 90. Now, 90 is a multiple, yes, of 5, and yes, it's also a multiple of 6. I know that we didn't include it in our list of multiples of 5 simply because Mrs. Schlecht ran out of whiteboard space, but I did circle it down here on our 6 multiples because I wanted to make sure that you knew that that is, in fact, a common multiple that they share. But we're not looking for just any old common multiple. We're looking for the least or the tiniest multiple that they have in common. And that, my friends, would be the first number that's circled. What on earth could it be? 30, you're right. That means that the least common multiple between 5 and 6 is 30. It just happens to be also the product when you multiply those two numbers together. But in the context of this problem, that means that lucky number 30 person in line, not only are they getting a free ticket, but they're also going to get that gift card. All right, my friends, that was just a quick run through over least common multiple. If you have any other questions, please let me know.